All right. Good afternoon, and welcome to what we call the graveyard session. Why do we call it the graveyard session? Because you just had lunch. The bad news is this is my second session of the day, and the first one was really full of energy, but that was 9 o'clock in the morning, so that was also bad. And now it's really a boring theoretical session. So if you fall asleep this time, I won't blame you. I won't show you a red card or something like that. Just don't snore, right? That would be already fantastic. Now, why is it a boring session? Because I'm going to talk to you about backup. I'm going to talk to you about backup over some time in HyperV and how it's going to be in 2016. And, the first thing you need to know is it's completely different than what we see today. But the thing is, before I can do that, I actually have to explain what is VSS. There are two ways I can explain this. I can use the official Microsoft language on this one, which is really boring. Or what I'm going to try, and this is really trying, so I can fail, right? Is I'm going to try to explain it very simple, level 100. So what I did before I came here, well, a week ago, because I come from Vienna actually this week, is I did the session before my wife. Now my wife in IT, that's something which doesn't work. And she claims she understood what I said. I'm not sure if that's true, but we'll see how it goes. You can say afterwards whether I succeeded or not. So what we're going to see today is what is VSS. Again, I'm going to keep it briefly, try to explain it as simple, and then we're going to go over HyperV in 2008, and actually even virtual server for those of you who still remember that one. We're going to talk about HyperV 2012 R2, which already was a major change between 2012 and 2012 R2. Then we're going to look at HyperV 2016. And, if the demo gods are with me, this morning I had some issues, then we're actually going to show you what happens as well. Now, one of the things also I want to give you as a takeaway is, especially if you're the persons who are responsible for backup in your environment. First, sorry about that, but, I've been 16 years myself in backup, and for some reason I like it. Because of those changes, that will reflect also the way you're going to create your infrastructure and the way you're going to design resources. Now, for once, it's a good change. And if they succeed in what they're doing, and I have to admit it's already pretty good in TP4, then those who are running Hyper-V will really have some advantages when it comes to host-based backups and doing your entire virtual machines. So let's hope for the best by GA. That being said, let's look at VSS. So what is VSS? It's Volume Shadow Copy Service. This thing was introduced in Windows Server 2003. Why did they introduce it? Well, actually, Microsoft's idea behind it was you need to be able to take a backup of an application, SQL, Exchange, Active Directory, those kind of things, while it's running online. Because what we did in the past was we kind of paused the application. Now that can work for a database of 1 gigabyte. Imagine a SQL database of 50 terabyte that you pause. You can do that at night, but we live in a 24/7 world lately, so it doesn't work anymore. And it's meant to really create that point-in-time copy. Now, some of you will call this a shadow copy, other ones will call it a snapshot. It doesn't matter. We're just looking at a point-in-time copy, and whatever you call it, we can live with that, right? It operates at the block level of an NTFS volume. And what it does is actually it makes sure that the moment you have those contents, they're not changing while you're taking the snapshot and do some work on it, move it away to some storage or whatever you want to do with it, and that the files are not locked as well, because if they are and you try to recover it, that will simply say, sorry man, but this is not going to work out well. Something is fault. Something is inconsistent. So you don't want that. Now it exists, everybody says it exists out of 3 components. You've got a requester, you've got a writer, and you've got a provider. In fact, there's actually a 4th component, which is the service itself, and which is the one that kind of coordinates everything all together. But mostly when you look at documentation online, you will only see those 3 components. Just know that in between there's also a service that makes sure that those components can actually talk to each other and work together as well. Quickly, those three components explained. A requester is the application that will say, I need a snapshot, which is basically a backup application. Whether this is a third-party vendor, whether this is the Windows Server backup, as it's been called now, or whether there's you doing some PowerShell, it doesn't matter. You are requesting that backup. You're requesting that snapshot. And then it goes to the provider, and the provider is the guy that's kind of going to coordinate everything. That's the core of VSS. That's also, that service in a matter of speech. And he's then going to go to the writer and says, hey, look, somebody just requested a snapshot. How many writers are there? And a writer, you have to look at a writer as the guy that knows how to make sure the application can be ready to take a backup. Still pretty simple, right? Now, on a system, there probably are multiple writers because you have a writer for Exchange, you have one for SQL, Active Directory, System, CSV, if you're running CSV, you have a HyperV writer, and there are a lot of third-party software out there that has a VSS writer as well. The good thing about this is that every software that provider who write the software, they know better how to stop or pause that application to make sure it's consistent. So they need to do it themselves. The bad thing is that some of the applications didn't always put a lot of attention in it, and sometimes we had bad writers. But we're not 2003 anymore. Everything got improved, so lately most writers are rather stable. So that's good. Okay, this is probably one of the most ugliest designs you can find at TechNet. This is their explanation of how VSS works with a lot of arrows. What you need to know about VSS to understand what happens, and when I go to the next diagrams, is, again, you got a requester. It goes to that follow shadow copy service, the provider. The provider then says, hey, writers, get yourself ready. The writers do that. The writers go back to the provider and say, hey, we're ready. One of these providers, which could be a software provider, could be a hardware provider, then says, I'll take the snap. And then goes back to the requester and says, I'm ready, take whatever you need and let me know. That requester does something with that snapshot, whether it's copying off to another location, whether it's copying off to another volume, it doesn't matter, it does something. And then we'll say, I'm done. Goes back to the provider, and the provider says, cool, we're done, let's release everything and merge the snapshot back so we're back where we started. That's the simple explanation. Compared to when you go to TechNet, you'll read a block of text like this, which basically says the same, but make it more sound scientific and interesting. All right. Now, how a provider can work? A provider can work in three methods, where it's a hardware provider coming from the storage vendor or a software provider from Microsoft itself. It got a way of doing a complete copy, also known as a full copy or a clone. Again, whatever you use, it doesn't matter. It's a full copy. It's got a copy on write, and it's got a redirect on write. Now, very quickly, a complete copy is broad and simple. You've got your data, and we basically make a full copy of that data, and we split it. At that point in time, everything can continue on the complete copy, the real original production data. But you got that other one where you can do your backups on or some transforms or whatever you want to do with it, and there we can work on. Downside, well, if you got a 50 terabyte virtual machine and you take a complete copy, I hope you have the storage. And storage isn't cheap, of course. But that is one way it can work, but it can also work according to a copy on write method. And what we here have is that when there's a change, and in the graphic I'm using, right, you got the original data, you got 1, 2, 3, 4, 5, and we're going to change the 3 to 3 accent or something like that. Before that is written away, we first copy that 3, the block that's going to be changed, to the differential area, which is where you keep the snapshot. And from the moment we're certain that it's there, we're going to change the block. Which means at all times, even if something goes wrong, we had that change on the other side. So we can revert to that point in time. What is the downside of this method? If there are many changes, this can be a very expensive operation on your resources. Not only on the storage, but compute and all of those things as well. Then we also have the redirect on write method. Again, we're going to do the same thing, 1, 2, 3, 4, 5. We change 3 to 3 accent. But now what the shadow copy is doing, it's going to get the differences only. So the original data kind of changes on the production story, but we keep the changes on the differential area. What's the downside of this? Well, the upside is you have less writes. The downside is if you got a lot of reads, he not only has to read the original data, but then gets referred to differential area as well all the time. So both methods have ups and downs. Luckily for us, the provider does most of the time a good job in looking at what is best, or you force those providers through a backup application to use what you prefer. Then we have got, the difference, what type of providers. We got the hardware-based providers. Those are the ones that work together with the storage on a storage ledger, which theoretically was one of the best moves Microsoft could have done compared to the way that VMware works, because that meant all of that resources, all of that compute you need, and the storage I/O has been handled by that very expensive storage box you bought, and your hypervisor wasn't really touched on resources. What was the biggest problem we saw over the last years? That most of these storage vendors, their hardware implementations weren't that good. Luckily, they're changing as well, but still, it wasn't always what we wanted. Software-based do it differently. They kind of get between the reads, IOs, and the requests in the software layer, and creates those shadows copy on the software layer, which means you need enough disk at the software layer, but that also means it's consuming resources from the OS, right? And then we got some specific providers that will give you some additional work. Again, I'm not going to go into deep, but a system provider really specific for Windows operating systems. That one uses specifically copy on write. You need to have an NTFS volume, but I'm hoping none of your servers is still using FAT or FAT32. Otherwise, we need to have a talk, and I need to send one of the consultants in your direction. And if you ever get into trouble with that DLL and that sys file, that means there's a problem with your shadow copy functionality, right? Writers, I already talked about it, so I'm not going to go in depth anymore, but they're the ones that quiescence your application, okay? Good. Now let's look into the history, because that is what we're doing. So in the good old days, well, the beginning of the virtualization steps of Microsoft, we had Virtual Server 2005. Guess what? They brought that out, and the first question they got, what about backup? And Microsoft basically had nothing. It was impossible besides stopping that virtual machine, copying the files, and starting the virtual machine again. That's not good. So 2005 R2, they were building it, and at the same time, they were actually already starting deploying and architecting 2008, the first HyperV server. That kind of happened at the same time. So they realized we need to have some kind of architecture. Now keep in mind, when they designed this, they were looking at one host running 4, maybe 8 virtual machines. So this is how it works at that point in time. We've got the host, we've got the guest, there's a file system filter there. So the backup application is doing the requests. Excuse me. Goes to the VSS and say, hey, want a backup, right? Talks to the HyperV writer or the Virtual Server 2005 R2 writer, whatever you want to call it. That one knows, all right, but I know it's a virtual server, so inside we've got, again, VSS and so on. So actually what happens is the entire story starts again. The HyperV writer goes inside the integration components, which has VSS again, and says, hey, I'm the backup application. Do your work. Again, we're going to go to VSS, the provider, and then we got the actual writers that do their job. So we receive a guest snap. That's what we get at that point in time. The writers come back, talk to VSS integration component, says we're done, going back to the HyperV writer one level down in the host. And then VSS in the host says, you're ready, okay. Now we take a host snap. If you look at this graphic, you see that there's a difference between the guest snap and the host snap. That difference is a amount of time. Could be 20 seconds, could be a couple of minutes, could be depending on your infrastructure. Now Microsoft has solved that. They use some magic to get it fixed. Reality, the magic is what they're going to do is they're going to mount the VHD they have at that point in time, do the rollback until the guest snap, remove the rest, then close it. Now I think you can hear here that means a lot of resources that need to be used just at that point in time, because another virtual machine suddenly gets mounted. It's invisible, but it gets mounted to your system. So that works when you have 4 virtual machines or 5, but what about when you have 20 or 50 or 100? So they realized, yeah, that's not going to work that well, especially since the hardware vendors saw, virtualization. We need to build bigger, better boxes so they can run more and more virtual machines. We need to figure this out. As I said, not scalable, very limited, and if there are a lot of VHDs to be mounted at the same time, let's say you want to back up all virtual machines at once, this could really take ages. Okay, enter HyperV 2012 R2. When they changed the architecture of that backup, what they said was, look, we want to set the scene for shielded virtual machines, which never made 2012 R2, is something for 2016. So at that time, they were already thinking on an architecture for the next version. And then secondly, of course, because of all the complaints they got, they want to increase that reliability of the backup. So if you're going to look at how it works now, the first part is actually completely the same. Again, the backup application, VSS, going to the HyperV writer, going inside the integration components, talks to VSS, do the writers, and we got a guest snap. The difference now is that when it goes back, HyperV VSS provider, we have now an AVHDX, or a snapshot. The advantage is that because of that, we don't need to do that mounting anymore, because we can actually take the backup from that VHDX, which is more or less read-only at that point in time. And all the I/O, or the writes, happen in that AVHDX. The VHDX still can be read by the host, because otherwise the computer can't continue to run. But we can do our job, we can export it, we can move it to some storage with knowing that it won't be changed, so it will be consistent. Now this was a big improvement because the mounting operation was removed. But it's still not great, because if you remember or you have seen this already, at a certain moment in time the backup is done, and then you have to merge the VHDX with the AVHDX, and that still could take a lot of load, a lot of resources on your storage. Especially when you look at the system and you have, for example, a CSV, and there are a few hundred virtual machines on it. When you take the snap, you're literally snapping all of these virtual machines, even though if you're only backing up one VM. Which means afterwards, all those 100 virtual machines still have to be merged again taking a lot of time. So still some issues here. It doesn't work yet. One of the tricks also was in the beginning, if I quickly go back, you see the first HyperV writer, it wants to have the metadata to be able to do that. Unfortunately, at that point in time, it doesn't exist yet because we didn't create the AVHDX yet, which means you have to work with GUIDs. And those GUIDs need to be passed through. There were all sorts of issues. HyperV needed to be able to hot add and remove VHDs as well. Actually, that's the reason why we got the technology in the first place, which is good, of course. And then, as I said, that scalability, think cluster 800 VMs, not abnormal anymore these days. It really took a lot of time. So, more that needs to be improved. Now it becomes fun. Let's look at HyperV 2016. So how are they going to solve that? And it's completely changed. The architecture is completely changed, which comes with some challenges for probably some backup vendors. But you know, I think there are good challenges. There's no more file system filter anymore. That's already very important, which means if the third-party vendor, and with third-party I actually mean DPM as well, because that's seen within Microsoft as a third-party vendor also, they don't have to write this themselves, which decreases the possibility of blue screens and issues with it and so on. But we still got the backup application, and now it's going to talk to WMI, HyperV WMI. And then it talks to VSS and VDS, right? Well, what happens now is Still the same in the guest. We've got the VSS integration components. It does the VSS, goes to the writers, and we got a guest snap. The difference is now, the moment the snap has been taken, it will also, at the exact same time, take a host snapshot. Whether this is a software snapshot or a hardware snapshot. That means the hardware VSS provider, as we know them with those storage vendors, will go away, and we get the possibility that VMware already has for years. Now, applications will be have the possibility to integrate with that storage vendor and really take advantage of those capabilities, of those snapshot capabilities, releasing the load of that hypervisor. So it becomes really interesting. And because of this method, they will be way quicker of releasing that AVHDX, merging it, and the smaller of the time the AVHDX is running, the faster it merges, the better it is for your resources, right? But that's not enough. One of the things that Microsoft also doing is building their own change tracking system in 2016. Because what you see today are vendors that have their own change block tracking, but there are some issues with that. And I'll try to explain that as well on my, how I explain it to my wife. Let's just put it like here. We've got some data, some raw data. What is the best city? You know, we take an initial backup. That's pretty easy. Everybody can do that. And somewhere we have a full backup on some storage that says, what is the best city? Now we start to make a change. What happens is, Oslo rules. Now as you can see, in memory, we have a bitmap with change block tracking that actually tracks which blocks are changed. Not the actual data, but the blocks. And as you can see here, there are 4 blocks that are changed, and if we then take an incremental backup, it actually sends data over to the backup that was already there. Why? Because that specific one was in that block as well. So if you ever say, why is my incremental backup larger than what I actually was changed, that is probably the reason. There are many other reasons as well, but this could be one of the reasons. So we take that incremental backup, that's great. We put it there, or whether it's a differential backup, and then, you know, depending on your settings, you can merge the backup and you got a new full again. Still pretty simple, okay? Worked, most vendors could do that very easily. Now we make some more changes. I agree that Oslo is a great city, and I actually do, by the way. But then we have a power failure. Or we migrate the virtual machine to another host. Don't forget that in-memory bitmap is on the host. And we're doing that, and, well, bye-bye in-memory bitmap. We lost it. So we don't have it anymore, and the only way we can get back to that change tracking, to that incremental, is by either do a full backup again, which is not the most fun to do if it's a large VM, or do a checksum, which is not much fun if you have a big VM. And that is one of the big issues everybody has today. So whatever happens, you kind of need to start again, and you might wonder, why is my next backup taking so long? Nothing has changed. Well, you might have had a power failure, or you might have migrated the virtual machine, and everything needs to be calculated again. So that's not good. Enter Microsoft in 2016, and, you know, they said, we can do this better. Enter resilient change tracking. Instead of change block tracking, they call it resilient change tracking. It's a name, but let's look at it just exactly as we did. Again, what's the best city? We'll take a full backup. Nothing has changed, exactly the same way, right? Then we're going to do some changes. We're going to do some changes, and we say Oslo rules again. But now we have a bitmap in memory, as you can see right here. And note, I'm not using X's anymore, but I'm using ones. This is going to be rather important for a few slides further. But we're also going to have a bitmap on disk. Notice that the blocks on disk are larger than the one in memory, which means continuing with RCT, the in-memory bitmap will still be the one used mostly. It's only when there's an issue, there's a failover. There's a backup of the bitmap. So we do the same thing. We have that backup. We might merge it. We might not merge it when you have incremental forever or whatever technology you're using. But what happens when we do some more changes? Now I'm saying it's amazing, and now you can see the number 2s. What happens now in these bitmaps is it's going to maintain 1, 2, 3, going to maintain numbers. They're not literally 1, 2, and 3, bit different, but to follow, which also means that now the HyperV host keeps tracks of the changes between snapshots, which make your life easier if you take a couple of incrementals after each other and then need to do a merge, a synthetic full or something, or even when you need to say, I need to recover, I only have incremental, like 5 increments and 1 full, we don't have to do specifics in the back, we can go directly because we know only the 2s are changed. So even for recovery purposes, all third-party vendors, DPM, Windows Server Backup, or PowerShell, as you will see later on, should be able to take advantage of this, meaning the restore will be faster from incremental backup. So that's a good thing. But you can see we've got 1s and we've got some 2s. So this time we got a power failure again. We lost the in-memory backup, bitmap, sorry, but we still have that data on disk, which means we bring back the system and we can still do that differential backup and then even merge it as well. That also solves the problem when you move your virtual machine from one host to another, because at that point in time you lose the in-memory bitmap, but because that other part is on disk, it just gets migrated as well, so it can keep track of the changes until we have another backup and then use the in-memory bitmap again. So it really solves a lot of things here. So what you see here is we've got that initial backup, we've got one differential, the 1, and we got the differential with number 2, which you can see here as well, and then we got the merged backup. So now we kind of have a history. So pretty much good stuff. What do you think? This can solve a lot of issues, right? Yeah. Now the funny thing is it actually solves even more issues, which was never planned, but still that's a good thing. Because one of the things many backup vendors do is make something which is called synthetic fulls. Instead of taking a full on your production, they will just take somewhere on the storage background, have the first full they ever have, and then merge those incrementals in there at a, I don't know, weekly basis, 2 weekly basis, depending on your choices. This system will allow them to speed things up as well, just because they have that bitmap and they can use that to create a new synthetic full. So that is great news as well, right? Now, let's look at a full backup visualized. Just for a minute here, how it looks now. So we start with a new virtual machine. It's got no existing backup, no user state, nothing. We got our production, our running virtual machine, running on a base VHD or VHDX, right? So first, what happens is we take our full backup, we fork the virtual machine configuration and the configuration file as well. That means even if there are changes to the configuration file at that point in time while the backup is running, it won't be directly applied to make sure that what you have in your backup target is consistent, okay? So it's forked, they're ready, we move the base VHD, we move the virtual machine configuration, and instead of doing some fancy stuff now, they realized export is what you can use. Everybody probably knows if you go into HyperV Manager, you've got this button called Export. That works great. And why is that? Because they have now something which is called Production Checkpoint, the way it's going to take the snap, which is going to be supported in production. So all what's going to need it now is a real production checkpoint, an export, and it's on the backup storage. And that's actually great news. It also means, by the way, in 2016, you will be able to checkpoint your environment live for doing something, and it will be supported. So again, an advantage that we are getting with this technology. Okay, that is great. We've got that virtual machine. It's got on the recovery storage, and at that point in time, what happens on the production is that there's a change tracking information starts to run. T1, or the one, you know, in my previous slides, right? And that is going to keep those changes in those 2 bitmaps. And we're running, which is great. Oh, one thing I forgot to say, of course, after the backup is taken, we merge the A VHDX with the VHDX again, of course. Now let's look at an incremental backup, and we're going to kind of doing the same thing. We already got the running virtual machine. We got one full backup. We're going to say, let's do it, and we take a backup. Now the biggest difference here is, here we go. It's the same process. Again, we're going to fork the virtual machine configuration. Again, we're going to fork that VHDX, and we're going to have an A VHDX. However, the nice thing now is we only need to send over the blocks that has changed because we have those in that tracking bitmap. So we send those over, should be faster, should be great. And what we get at the recovery storage is we've got a differential VHD. We got again an exported virtual machine configuration. And now it's up to you or the software or whatever been using to choose whether you want to merge this or keep those as is, those different points in time. And what happens afterwards when the backup is done, we do a merge again of the AVHD and the base VHD, and T2 is being created. And T2 then starts doing that bitmap operation again and making sure that it tracks the changes. Okay? We got T1, we got T2, and then again, there are possibilities to delete one of these points in case you know, well, I kind of merged all of these incrementals into a full. I don't need them anymore. They're 30 days old. I'll just delete them. Or you can keep them, hopefully not forever, because that will take some place. But those are the things you can do. And then it just continues, T3, T4, T5, till 2, T, whatever. Okay? Still more or less clear? Hope so. Must be a good lunch. As I said, there is a possibility to do a previous reference point, that T1, that T2, to delete it as well. I'm hoping for most of the cases it will be the backup vendors doing that, but you will see that PowerShell can do that perfectly as well. Just take into account if you're building up a string and you are going to go manually inside and delete somewhere a point at that string, you might break something. But it is possible. All right. And then, as I said, an optional way is, and that's a great opportunity as well, if you want to use a synthetic full, don't take another full backup, just merge on the back end those two together, so you got a new full backup. So what about the restore? Restore is actually very simple. Let's go from the point that we were stupid and we deleted the virtual machine, or we broke something, or whatever happens, it's gone. And in our example, we actually had a merge. So we have two full backups, more or less, on our backend. Well, since we kind of used the principle of exporting, guess what? We can actually do the same thing, but then import that virtual machine. Why? Well, we've got the VHDXs, or one of them, two of them, 10 of them. We've got the virtual machine configuration. The only thing we need to do is copy that data back to the production storage and do the import. Just like you do it today when you move a VHD from one side to another side and go manually to HyperV Manager and say import. That's exactly what's going to happen in 2016. That import operation will have an API now, so it can be invoked by different types of solutions. And the nice thing as well is that it will allow you to, even if you do an import, to modify a lot of things. Where you want to store the VHD, how many memory it has, what are the paths, what is the configuration, and so on and so on. You want to keep the same HyperV ID, that is perfectly possible. Do you want to generate a new one? Whatever reason, that is possible as well. Meaning that our third-party vendors out there will get a lot of possibilities to do more restores than just recover entirely or recover a little bit. So that is all good news in my point of view. If we're going to work together with Sans and they're going to do their implementation, it even gets more interesting. Because when we then have the starting point, and again, new virtual machine, no backup, we're going to do exactly the same thing. We create T1, AVHD. We're going to move that to a LUN snap. We leave the AVHD and the base VHD there and the exported virtual machine configuration. The other one can be merged instantly very quickly thanks to the SAN technology. So your production continues to run, and we suddenly have more opportunities. We can do merges there as well. We can do some things with the checkpoints, whatever you want. But just follow here where we have that LUN snap, and we keep that LUN snap. Now the nice thing is, if you delete it, everything continues, but you can continue to keep all that information on the SAN. And when we're going to go with the restore, it even gets better, because guess what? We delete the production virtual machine. Oops, we've got nothing anymore. Now, the only thing we need to do is actually send the exported virtual machine configuration back to the HyperV server, use that to import, but since we got a LUN snap, most of your vendors will actually be able to just map it, which means the time to restore is the time you need to copy that virtual machine configuration, which is very small, back to the HyperV host. That is almost instant virtual machine restore, which is great, because if you do something wrong, you will be able to recover very, very quickly. So really interesting technology, I think, giving additional possibilities. Of course, there will be some downsides. I mean, if you keep a lot of those LUN snaps, you're going to need a lot of storage. And I think those SANs mostly aren't cheap. Storage is cheap? Yeah, sure. But that is great things we can do. I already know that there are people working on technologies where, you import that virtual machine configuration, it gets started, you have an instant restore, and then in the background you're going to migrate that LUN snap back to the other LUN and then delete it or something like that. So there are many, many possibilities that will become possible. Let's have a look on how that works, because theoretically you don't even need a backup vendor anymore. The way they implemented it, I can just show you by using PowerShell. Now, assuming most of you won't be playing with PowerShell commandlets the entire day just to take backups, but it is possible. What I've got in this environment is I've got domain controller, fun, and I've got a core server. Why a core server? Not because it only works in core server. It's a guest, and I need to save on resources with this machine. What else do I got is I've got some PowerShell. Unfortunately, this demo is just PowerShell. But what I can show you is, if you want to, but let me skip that, is just do a VSS admin of a guest, how many providers it has. I normally do that to my domain controller to show you that there's a specific one for Active Directory and for DNS and those kind of things. But, more important is this one. What I've got here is a script, a module that's been created by somebody of Microsoft. At the time, it was TP2. I've modified it last weekend, so it works with TP4. It's at GitHub. If you want to play with it, unfortunately, the downside of GitHub is if I upload it there, somebody of Microsoft still has to approve it. So waiting until that approval. From the moment that's ready, you will be able to just download it. What do you need to know about it? Let me just show you. Hey, yes, you should. Thank you very much for telling me. Do we see something? Wow. You could have let me do here a demo for 10 minutes and just sit there, right? Yeah, that would have been fun. One of the things you need to know about this module, it's not signed. It's written by him. I adapted it, but we don't have a certificate or something, which means your execution policy needs to be unrestricted. And then the only thing you need to do is import the module. Why do I have remove module in my script as well? Because at the time I was modifying it, I was testing, which means if you make a change, you need to remove it first, import it again. Don't do that too often. That's good for testing purposes, but don't do it too much. All right, so we're gonna import it if it wants to. Here we go. Oh, right, sorry. I need to make sure. Oh, I'm still up my domain controller. That's better. I still was remotely to my domain controller. Now at the right directory, and I'm going to import the module. Why do I do verbose? It's just for me to see what kind of commandlets I'm loading and which ones I'm removing. You don't have to do this, but it was when I was playing with it and building it. And then we're going to create a backup. What I'm going to do is I'm creating a variable called checkpoint. We're going to use a commandlet inside that module that was created, and that will use WMI to do its work. And we're going to connect to a virtual machine called core01, and we use the consistency level application consistent. Before I actually do that, let me quickly jump to here. This is my server. This is that virtual machine. I'm going to go to the settings and show you something right here, which is already a big change. But now you have the possibility to enable checkpoints and to choose production checkpoints, with the possibility to fail over to standard, the ones from 2012 R2 and before, if necessary. If you really don't want to use this new technology, you can still go back and use always the old ones. I don't see why, but it is possible. So I'm going to use that one, and I'm choosing the consistency level application consistent. You can also choose crash consistent. If you know that you're running a virtual machine which doesn't have VSS inside, use crash consistent to make that happen. So I'm going to start this backup. Here we go. And the job is running. And now I need to be quickly, but what you're seeing here is creating a checkpoint, right? Just like you would do it manually within HyperV today in 2012. Now while it's creating, it's actually finished already. That's why I use core, by the way. You can actually see now we got my checkpoints, core 1, and what is running at this point in time. And if I then go quickly to here, which is the location of that virtual machine, you will see I've got a snapshot, I've got a VMCX file, VMRS file, and we are running on a snapshot as well. When I go to my virtual hard disk, you've got the VHDX, you've got RCT, which is the resilient change tracking file where it keeps that data, and you've got an AVHDX file, right? Good. Next part I want to show you is a backup vendor then would want to export that backup to a certain location. Let me just change this a bit. Otherwise, it will tell me that directory already exists. And I'm going to export that backup that I took to that specific destination, right? Still very simple. Run the selection, and the job is running. And again, I have to be quickly, but you see the status right here. It is exporting. Okay? Still simple, but that is what I showed you in a visual. You can actually do that today in TP4 as well by using PowerShell and WMI commands. While it's doing that, I can actually show you, if I'm not mistaken, I was going to, was it backups? Yeah, full 02. And then you can see here the virtual, which is now growing in size as well, because we're doing that exact export. Yes, this will be faster on decent storage. This thing is not even having an SSD, so, but even then I think it's rather nice how it works. While it's exporting, let me explain you a few more things. Then you have some commandlets in there that will show you how many backup checkpoints you have, but also how many reference points you have. Now, since we're taking here a full backup, I don't have any reference points yet, but you will see that in a big second that we can actually do that as well. In the meantime, job is still running, so I can't do anything but know that. Some other things I want to show you while this job is running is converting. So again, I'm using a variable, convert, just to store the information. The job will run, but I need that afterwards to do some more tricks. So what we're going to do is we can convert a VM backup checkpoint on that storage, which means we've got a full, we got a differential, and we're going to add it together. Okay, that is what I also showed. It's actually running slower than expected. For those of you who really want to go deeper in it, and if you open that module later on, you can see it. I've blanked it out here, so I can't run it, but one of the things we do is we have a variable, virtual system snapshot service, and we say get WMI object in the namespace root virtualization v2 and talk to the class virtual system snapshot service. And that is where all this new functionality has been stored. There are a few more classes that you need to use, but they're all in that script and explained as well. If you're wondering now, is this backup going to fail because it remains at 57% for a very, very long time? I'm not sure why that happens, but it always keeps 57% and then suddenly it moves away and before you know it's 100. So maybe maybe something in my script, maybe still a bug they need to fix, I'm not sure, but that is what happens. Okay. What else do I got? See, now we're done. Yeah, must be something like that. Yep. Waiting until that's done before it actually does the percentage. So we probably need to update the script to make it a little bit more beautiful. But you know, we've got a PowerShell guru in here. Maybe he can do that for me because mine is a bit less. Let me see what kind of checkpoints we have. We're quickly going to run this one. And it actually shows me the type of snapshot. So it's on my HyperV 4 host. I'm using a snapshot, right here. And then it actually got a lot of metadata that I can use as well for further actions. See, what is the element name? What is the time? Where's the VMCX file? Where's the configuration data route? And so on and so on. So a lot of information that will be able to be used to do some very advanced, nice type of backups. And then even boot source order and those kind of things. Let me quickly check because I seem to remember that this morning I actually tried my demos. I might already have some reference points, and I actually do. Which means I have here different types of reference points. And now that you mentioned this, I actually have here some deltas where we have virtual hard disks. Which this one is a full actually. That should be better. No. Where is it? Seems to be full all. Let me quickly check here with the real virtual machine. Core, why did I ever call it test? I don't know. But now you can see we're actually making reference points. We're storing that RCT data so that can be used as well. Now the last thing I want to show you in this demo, and actually kind of have to hurry up as well, is that convert. So what I'm going to do is simply run it, and what will happen is now we're gonna convert that snapshot. Because this is very important. Until that time, I was still running at AVHDX. The longer I wait with this, the more difficult it gets. Now again, this environment really isn't doing anything, so it's kind of an unfair demo to show you and say, see how fast it is. But you also have to think about REFS 2. And those of you who have been following a little bit what Microsoft is doing in Windows Server 2016, sorry, they know that they're optimizing REFS version 2 also for backups. And if you know REFS, then you also know it works with metadata. So that means if you got your VHDX and your AVHDX, instead of merging it in real life and doing all of these writes, suddenly you're just going to change pointers, which means that merge will be way more faster. So if you're already working with Windows Server 2016 today, well, hope not in production, but if you're working and playing with it, then make sure you've got somewhere one volume, not the C volume, but the other volume where you're storing data, and store that on REFS instead of NTFS. And the benefits of that, especially with this type of technologies, will be very huge. Even just creating a VHDX, a full one of 127 gigabyte, if you do it today on NTFS, you start, you get a few coffees, you come back, you're going to get more coffee, and then maybe it's been created. With REFS in 2016, you started, you're not really creating a 127 gigabyte file anymore, you're creating metadata. So it's way more faster. So also very interesting technology that together with this gives you great benefits, right? So this was my demo. To keep it very simple, what I did is I did first a snapshot, I exported it, and then I converted it so that the VHDX and VHDX come together. Just quickly showing you, where is it? Nope. Sorry, let me quickly refresh. Here we go. So the module that's been created is called HyperV Backup. What do we got? A couple of comments. We got that conversion. We've got the export. We got the get. What kind of backup checkpoints do I have? How many reference points do I have? We got the one to make a new one. And then we also have a commandlet that is to remove one. And the remove one will actually remove that T1 or T2 as well. All things you can play with. Let me quickly also see right here at my scripts. If you then want to dive deeper in it, this is the HyperV backup, originally created by Taylor. Why did it suddenly do this? And that's it actually. This is the PSM1 module. The first one, filter process WMI job, you don't have to care about. Why are we using this? This is a generic component that can look what you do with WMI, and if something goes wrong, it gives you an output. But the important ones, of course, are the ones where you, for example here, the convert VM backup checkpoint, where you can actually see and then use something like WMI Explorer, which WMI calls it's doing, which it needs, and see what type of information it is. I know it's a bit geeky, but you know, I like doing it. All right, and with that said, more or less, do we have any questions on this part? Let me put it differently. Did I succeed in explaining it simple? Was my wife lying to me when she said she understood it? Probably she was, but still. All right. Great. If there are no questions, fantastic. Thank you very much for being here. I hope you enjoyed it, and see you somewhere next year.